Great. Hello, hi David.
Hello, Alex. How you doing?
Yeah, it's a great day. I love Mondays. And how is the
Learning
weather?
Mondays. It's
Yeah,
Learning Mondays.
learning Mondays. Uh, well. So I see people are joining our stream. If you can hear us and if you can see us, say something about that in the YouTube chat. You may write from where are you from. It's always very interesting how people from all across the world are joining us. That's gorgeous. Okay, hello guys, and it looks like we are good and it looks like we are fine. So, I suggest us to start step by step. Yeah, that's funny in the chat, like Finland, Amsterdam, Sweden,
Yeah,
and
we got
so
people
on.
from everywhere. It's I have to say, and I just typed this in there. It's kind of a fun, stupid fact. But for Santosh and there from Finland, we have some close Finnish friends. So both my daughters have Finnish in their names. One is Lahja, which is gift, and the other one is Lumi, which is snow. So
That's
they have other names, but they happen to finish in their names. What do you know? You never know.
that's incredible how world works in 21st century. I really like it.
Yeah, yeah,
Good.
totally.
Okay, so as you maybe know, or at least you should, that's DataStax Monday Learning, the special program when we are trying to make your Monday your favorite day of the week with Monday Learning, and we every week run courses and different workshops for the topics what will make your developers' heart hot. And this is the fourth release of our uh, Docker containers from basics to best practices course. It was 4 weeks learning path, but now it's 5 weeks thanks to you, because together you persuaded our bosses what you need Kubernetes, and we are giving Kubernetes now as the week 5. So it could have been end for this course, but it's not, because we will meet again next week to talk about how Kubernetes works. And regarding the things we did before, we did Docker fundamentals, we did application development with Docker, and today we speak about the best practices. So stick to us and follow this workshop and do one more now with introduction to Kubernetes, and get your final assignment to get your Docker upgrade complete achievement. And we are getting further. So this course was in a high demand, really a lot of registrations, and by today it was like around over than 2,300 hours of overall watch time, and it always makes us happy to see how you stay with us, and I hope you spend even more time doing your homework assignment. It's very important to keep up with a job. Like, you can listen to me and David 1,000 times, but if you don't do exercises on your own, it will not stick to your memory so good. So you will become a real expert. So you have to use that, not only watch that. Best practices. So before we go with the best practices, let's say a word about what we are going to talk about today. First of all, this class isn't going to be easy, because we have to cover pretty a lot of things. So Docker ecosystem and the amount of things to do, that's a long story, and there are many places to make mistakes. So, and there are many of best practices to enforce. And today is the overview of them. So try to get as much as you can from this show, do the assignment, and then you can make a deeper dive into something what looks the most important to you. But best practices isn't about to make your projects running, because, well, that's just base practices. And we speak about the best practices. What are they about? That's about maintainability. Worst enemy of any software, complex application, any complex system is the complexity. More complexities, that's harder to maintain, and we have to fight this complexity. Otherwise, at some point, we will not be able to bring any changes anymore and manage the system we are developing. So, best practices help you to ensure the maintainability of the project you are working on. Then, of course, security. Security is not the goal which you are kind of trying to reach somewhere in the end, but security is the way to put very important from the very first moment, not like you are developing something and you start to think, okay, now we develop it, now let's protect it. That's wrong, and that's very prone to any failures and exploits and so on. You want to think from the security from the very, very, very first step. We will speak about that today as well. And finally, error prevention. That's best practices, very often a great way to catch errors even before they happen, or at least even before they sneak into your production. So that's are the things we are going to take care of today. And we start with a simple thing. Size does matter, at least when we speak about Docker images. And we want our images to be very fit. We want our images to be like, David, what was the biggest Docker image you've ever seen or used?
Oh, geez. Many
Yeah,
gigabytes.
yeah.
Yeah, right.
Yes, and lightweight images are much easier to operate and much easier to start. Imagine you have your production server down, is on fire, and you want to spawn a new one and you are on the cloud, so it's kind of pretty easy. You spawn a new server, you are going to start your application there, and the image weight is around like 5 gigabytes. And it will be pulled for approximately a couple of ages, and only when it will be starting. And if you have image of 5 gigabytes of weight, it's going to be starting nearly forever, mostly probably. Yeah. So what we think of, first we want our containers to be fit, our images to be fit, and therefore we really think a lot of lightweight images. They are much easier to operate. And the first thing we work on is the use minimal possible base image. Slim Alpine Scratch, those words may say nothing to you, but I will show you to it, well, actually right now. Why wait? Some people underestimate the importance of a base image, but base image defines, well, talk is cheap, show me the code. Let's take a look. So, I will make us a little bit smaller, so you will see all the code. Boom. David, we are small again. No.
Yay. Oh, look at that. You shrunk us.
Yes. So, that's the first sample from today's week. And it looks by itself not so bad. And it works. So what is it? It's a containerized Python application, very small one. Application looks like that. It's based on Flask framework, very small miniature framework for Python, and all the application code is here. 5 lines, import Flask, and return hello world, kinda. That's all what you have to do. It's a hello world application. And when we have requirements, where we define what do we need to run this application, it's Flask only, so again only one dependency. And that's all the Docker files, so 3 files. From Python 3.7, copy files, set working directory, install requirements, and then cmd, what are we going to run when we start a container. Does it look nice to you? How do you think? Does it look nice to you, David?
Looks pretty clean.
Yeah, looks pretty clean, so let's build that. And I'm saying Docker build, I will set tag to make it easy for us. I will say it DataStax Monday learning first, like this. And I will build it here locally at, oh, stop. Of course, I have to switch to my folder. So it's going to be first sample. And now I build it. I really appreciate the time you spend with us. So I, of course, build it beforehand to save some of your time. So now it's done all completely using cache. Usually it takes a bit longer because we have to download base image. Base image we are using Python 3.7. And now let's take a look. I say Docker run. I have to forward the port. It will be port 80 on my side, port 5000 at the Docker side. And basically that's all what I need. I need a DML first and port is already allocated. Okay, sorry. I forgot to stop the old containers, but that doesn't matter.
Oh, that's right. I'm blocking some of the text, by the way.
Sorry. I will move it a little bit so you will not block that. Thank you, David. Stop blocking my text. What are you doing? Okay, so...
Well, we know that my chair is actually where my chair is transparent in the back, so I can just move out of the way.
Okay, so good, we have this application running, and just to check that, we can go to localhost. Localhost, open port 8080, the port I forwarded it, and we see application is here, so we have this hello world, loud and clear, and everything is fine. Okay, so it works. Now let's take a look at the thing. It works, but is there something what could have been done better? Let me say Docker images, and I'm going to grab DML first to show you. You know what? I will hide this Explorer, so now everything is fine.
I just ducked out of the way.
Yeah, thank you. So take a look at those nice numbers. 885 megabytes, almost 1 gigabyte. For what? For 5 lines of Python code?
You know, I wondered, Alex, when you asked me earlier how it looked, when I thought that there was going to be a little trick in there of this image is going to be like huge. And I don't think I was wrong.
Yeah, that's almost 1 gigabyte for 5 lines of Python code. Again, all the application looks like that. That's like not the best scenario, let's say. Let's take a look if we could do it better. So, first of all, I want to kill old containers. Okay. I'm not going to use them. First go. 384 go. EA8 go. Boom. Okay, I'm clean. Good. So let's try to take a look if we could do it better. And I bet I'm going to make it already much better with 5 characters. Only with 5 characters it will be already much better. So let's take a look. It will be Python 3.7 Slim. I will explain you what does that mean in a moment. Don't be in a hurry. But now I'm building this image again, and it will be DML first Slim. It again will be pretty quick. Okay, not so quick with cache and validation, but it's not a long story to install Flask, so it's done. Now I can run that. So I have this one, and it will be Slim.
Now, Alex, as you go to run that, Vikrant over on YouTube has a really good question here. Is there a way to identify such issues with Dockerfile, like a tool or something? Say you can use Python, and then it would almost like a linter for size, right? Where you could use Python Slim for better size management. Is there some tool for that?
Best tool for that is your brain. And that's kind of a joke, but also not joke as well. So we are setting up this tool to work with this kind of things. So you will know what's the base, what's the Slim, and what's the Alpine. So you will see and you will use that, and you will define how to use that and which kind of image you need at each moment.
So it sounds like what I just heard is you just have to be aware that this is a thing, right? And to specifically go out and look for, okay, I want to use Python. Is there a Slim version or something of it?
So there are linters indeed, and we will cover them today. But I'm not sure if linter can define if you are using like a regular image, but you could have been good with Slim as well. I'm not sure if there is a linter to define that. So, okay, we can go to localhost. This time it will be simply port 80, because I cleaned it up, and we are good again. So application is running, we see it in logs, everything is fine. I'm quitting, and now let's take a look. I'm doing the same Docker images, grab DML first.
And oh wow, look at the difference there.
Find the difference. That's
a huge difference.
Looks better. That looks significantly better. But do you think if I can make it better in some more characters? You know them.
I think the answer is yes. I have a feeling the answer is yes. By the way, Jipri has a follow-up here. So would there ever be a use case for just using Python 3.7? Would you always use the slim versions? Like, what are you getting for out of that extra 700 megabytes worth of image?
Yeah, let me show you this one, and I will answer. And final example would be, let me make this Python 3.7 Alpine, and I will answer this question because it's a good question which definitely deserves to be answered. And I'm building Alpine image. It's also done because I prepared that for you, and now we can run that using Alpine version, and it's going to be running, so I can renew it again, and we are good again. So here are my logs, it all working. I'm going to stop that, and now let's find the difference. Docker images, grab DML first. And Alpine version is 52 megabytes. So just by changing, just by adding some characters here in the base image, in the tag of the base image, we got from 885 megabytes to 121 megabytes to 52.3 megabytes. Isn't that great? I like it. Now our image is 50 megabytes, so it will fit into only 10 diskettes, 3.5 inches. Well, I hope you are not using those diskettes anymore. At least I don't. And but what happened here? So let's think a little bit. We have Python, and what is this Python? Python is an official Python image built by Python team and stored at hub.docker.com. You know that already from our previous classes. Then, what happens after this double point? All what happens after the double point is called tag. And tag is in basically any string you want to give. It's just, it can be some random characters, but of course we want it to be something more reasonable. So what is that? 3.7 obviously says the Python version of an interpreter we are going to have inside. And then, what is this Alpine then? Let's think. So every image has some base image. In the beginning, for Python, that's mostly probably going to be Debian. We can jump down and take a look, but that's not so important for us. Anyway, if we have this Python 3.7, which is kind of default image, it's a full-size Linux system with pretty a lot of dependencies installed. Full-featured system. It's maybe good for development because you have all the required tools you may want to have there, all the Python modules you want to have there. But obviously it's also not so good for production where you aren't going to use them so much. And then for slim version, you have the same base distribution usually, but there are some things cut off and there are removed some options. And it may be already operational, it works as you've seen, but it's also different. It's a reduced size. And finally, when we say Alpine, it's already completely different thing. That's absolutely another Linux distribution, which is also Linux, so-called Alpine Linux. We can go where that's open source as always. So we can go for GitHub for Alpine. And we have here Alpine Linux, just a tiny Linux distribution. And we have, of course, Alpine Docker here, Docker Alpine, which is the smallest possible Docker image, which is still kind of Linux. So maybe there are some smaller things, but the Alpine is one of the most popular. For example, if we say Docker images grep Alpine, the size will be 5 megabytes. So that's the default Alpine has inside. that comes with a price. Of course, there is always a price to pay. This Alpine has, obviously, due to this size, nearly everything what can be removed, remove it. As a result, for example, when you are doing, David, when you are doing docker exec -it container name bash, what will happen?
I expect to go to a bash prompt inside of a container. Or I can execute commands.
With normal container, not Slim, not Alpine, you will mostly probably go to bash inside the container, if at all, I mean if it has bash in general. With Alpine, you will get an error because there is no bash installed, because bash is too big for Alpine. And and you will get to SH because you can get only to SH because SH of the Alpine is the smallest possible shell for it. And so on and so forth. So, in general, for production, for many applications, we try to stick to Alpine. Sometimes it's very hard to implement your application using Alpine because, well, that's a special story. There will be no apt-get, but APK, how do you say it in English? Doesn't matter. And that's a long story. In some cases, you will be not able to make your application running with Alpine at all, and you should not by itself make it your holy grail. But that's important to remember. What size does matter, and we would like to have our images small as possible. Then, second interesting thing is a multistage build, but I have special slide for that, so I will show it to you later. Multistage is my favorite feature, or more or less new features of Docker, so I want to show it, of course. Then, I want my pointer. Yep. So, you know Docker file copy. Copy is the way to copy your files from local folder to the image. And we have to use copy carefully. And we have to copy only what we need. The point is, when you are copying the whole local folder will go to image. And if you are working in the folder with Git or .git stored somewhere inside, then mostly probably you are going to have .git in your image. And that's, again, mostly probably not what you are going to have. Another point, what it destroys caching. If you copy everything and one single bit and one single file has changed, then Docker has to invalidate the cache and build everything from scratch. And considering some layers below, some statements below, it may take a long time. So in general, when you are using copy, there are two main ways. Or you copying, specifying only the files you exactly want to copy this and that, but it may be like also not the best way, especially if you have a lot of files. Second way which I like the most is the Docker ignore. When you are using a Docker ignore, you can go like in our second sample, you can copy everything. So, okay, in this case, we are copying requirements. Okay, in the first sample, we are copying everything, and we have only 3 files here, which is not so bad. But if you want to stay safe, even from the future files, which may happen here, you can easily define .docker ignore. Docker ignore, okay, looks correct to me. And you can specify what should be ignored by Docker copy. So it can be, for example, if you want to avoid Git, it can be .git. And that's it. Git folder is ignored. But you know what? There can be Git in other folders of yours. And if you want to stay safe, you better do it like that. **/. This directive looks like a little bit weird, but if you use git ignore, you know what that means. It means file or folder .git in the current or any folders down recursive. And that's yes, that's something like git ignore exactly, but for Docker. So you can copy things, but everything specified in Docker ignore will never go to Docker image. Then install and clean up in one step. I will show you. It's impossible to explain without the Docker file. Talk is cheap, show me the code. And final one will be which numbers of layers. In most cases, less is better. Beforehand, and still there are a lot of people who think it is like that. Still, they are wrong. Before, nearly every of the Docker file statements added a new layer. Now it's not like that, it was fixed, and now there are only 3 commands those add new layers. Run, copy, add. All the other commands do not add new layers, and that's important to understand. I will show.
Yeah, Alex, got a question for you here from Severio in YouTube. Is there a Docker ignore global like the one for git ignore?
So that's a good question.
I agree.
Yeah, last time I've tried to use that, it wasn't a thing. It never existed. Maybe now it's a thing, but I can't answer right now. So maybe David, maybe you can take a look at the docs while I'm answering other questions. So question was, so there would never be a use case for just Python 3.7. We always use the slim versions from Japri Tsing. You see, it heavily depends on your system and which libraries you are using. For example, by itself, Node.js application doesn't have so many requirements. But for one of our use cases with Killer Video, we needed to specially compile it, and we needed to install all of our dependencies. We needed make, we needed G++, and so on. So it was a pretty big installment and a lot of dependencies. So I don't know what dependencies your project has, but in general we tend to use as small base images as possible always. There still could be a place for full image, especially when we speak about some development environment. You may want to have it because it gives some extra tools to you, which will not be a thing with Alpine, for example. Yep. And yeah, I think we can go on. And finally, run apt install needs version for caching and stability. What does that mean? Let me show you. For example, in the second example, we run apt get install vget. Well, first of all, this is a bad example. People started to ask me like it could have been done better. I know the second sample is exactly to improve this one, not to show it as how it should be. But what I'm talking about right now is to specify the version here. I don't know what's the last up-to-date vget version. I will put it like that. What does that mean? There are 2 points. First, when you don't stick to major version, you are going to install next one like 13. It's not a real vget 13, but let's imagine. And it may have some breaking changes, so your Docker build will not be operational after all, or maybe even you will find it out on production. So first thing, it may break your application completely on build time or even on runtime, which is worse. Second point, when you have it like that, that's easier to cache. And once it's downloaded, if nothing is broken upstairs, so there is no cache invalidation, it will be just reused from cache, and with some random vget, it may be updated, cache is broken, and then we have to do all of these operations again from scratch. What we would like to avoid. Good. So finally, now let's get closer. And finally, yes, utilize cache. That was exactly I was talking about right now. Copy as late as possible, as specific as possible. Put less frequently changed lines higher so we don't break cache. What does that mean? Let's take a look at this code from the first sample. We copy as the second statement. First one from, and then we immediately copy. Will it work? Yes, it will. Is it optimal? No, it doesn't. especially without docker ignore, it definitely doesn't. The point is, Docker utilizes cache heavily as long as you allow him to. And when you on a copy statement, there is only one way to calculate if cache can be reused or has to be invalidated. Basically, get every of your files, get the hash, and compare with the hashed value from the cache. And it's fine as long as I have like 3 files here. It's not so big job. But you are mostly probably going to have much more. And therefore, this process as it is going to take some time. But then second one, as soon as one single bit in one single file has changed, now the whole cache has to be wiped out and all the next layer's cache has to be invalidated as well. So one single point in a single file at this level, and all the layers has to be recalculated and rebuilt again, and in some cases it may take hours. Not on this one, but I know some applications with build time over an hour. So, what we want to have here, use copy as late as possible, as specific as possible. If I know I'm going to use only UpPy, then why shouldn't I do it like that? Oops. Dot is the wrong one here. So things like that. That's at first. Okay, I will need requirements as well, but that's not so important. Second, try to use in statements those that tend to change more often as low as possible. Directly low in this file, lower, down, or down. So take a look. I have my line 5 as a CMD. What is a CMD? CMD is a statement which will be executed when? On build time or runtime? On runtime, as the first action when I start a container. It's not executed on build time. Question, can I move it higher? Answer is yes. So I can sort of put it here, and boom, this line is cached already. And work dir. I can set work dir higher as well. I can set work dir here. I cannot move this line higher because I need file requirements txt in my up folder because I need that to define dependencies. But I definitely can make it like that. And as a result, I have those 3 lines cached nearly forever. And only copy will change, and pip install requirements txt will change, which I can optimize even better from the build time. Now take a look. Simplicity is very often an enemy of performance. Now this makes Docker file much smaller, so it's easier to read, and simplicity is great. But the build time, if I want to improve build time, how would I do that? Let me show you. This copy, as you're developing application, will break files, will break dependencies, will break cache nearly all the time, and cache will be invalidated. It means to pip install every Docker build, which is not nice. So what I want to do a nice trick. That's a nice hack, I like it a lot. I'm doing requirements.txt. I'm putting it to up requirements.txt, and I do pip install now. And only afterwards, I'm copying the source code. And what happened now, and why do I think it will work better? The point is, as I copy on the line 4 only requirements.txt file, it will not change too often. It will not change every time you put any changes into the application, only when you add some new dependencies or remove them, vice versa. So this file will not be changed too often. As a result, this layer, this run executions, this run pip install will be cached and will not be invalidated because all of those lines don't tend to change too often, or maybe don't tend to change at all. And as a result, only copy statement will be invalidated regularly, but copy is a pretty quick operation. That's it. We just improved the build performance, build time, decreased build time by the price of readability, by the price of adding some new copy statement. Question: does it matter? Is it the best practice or is it not so good practice? It depends on your goals. If your build time is the most important for you, do it to save build time. If you prefer to have things as simple as possible, easier to read for the human time is more important kind of at computer time, then you can remove it completely and keep the things like that. And there is no single correct answer, but that's for you to decide how you want to see that.
So Alex, I got a question for you on that.
Shoot.
In the example you just gave, when you were explicitly copying over the requirements text first, then later on, when you're copying with dot, right, you're just going to pull everything, I would think, including the requirements text.
Yep.
But is it because are you actually then recopying that, or because it's now cached, it kind of ignores it or something? What's going on there?
It's a recopying. It will be.
You are recopying.
It will be copying again, but as it's a single small file with 1, 2, 3, 5, 10, 20 lines at maximum. I mean, come on, how many of the dependencies you are going to have in the requirements?
It's not that big deal there.
Yeah,
right.
So that's not a problem. That's, I mean, some microseconds. I don't care.
So JetBreed, by the way, has a follow-up there. Wouldn't that first copy add another layer? We wanted layers to be less, I thought.
Yes, we want, yes, copy adds a layer. But what is a layer? A layer, first of all, is a change set. We will cover it exactly on the next slide. So we try to have as small layers as possible, but that's again not a holy grail. In the end, we do all those things for you developers to be more convenient to develop an application. And if you have to wait for 3 hours for Docker build, that's obviously the wrong thing. But as it is, one single layer is not so bad by itself. So, I mean, what I don't want to see is 200 layers. 300 layers, but one more layer by the price of, I mean, how much this pip install took. We did it just, I mean, some minutes ago. It took like 5 seconds. But this layer will also be very small. So I save it 5 seconds on every build. I do almost every build by the price of
when
some
I've seen
bytes.
pip installs that take a lot longer than 5 seconds,
Of
that's for sure.
course.
So,
of course.
Without making that optimization,
Yep.
you're paying that every single time you rebuild this.
Yep. Yeah, correct. Okay. So, and then second point was, so put less frequently changed lines higher so they don't break cache. Copy as late as possible, as specific as possible. They actually are, for the same purpose, utilize cache as heavy as possible. Then, enough of weight training exercises. Redundant layers. And now, as said before, every run, copy, and add will create a new layer. First example, create 2 layers, while second, only 1. So we see here, we have run apt-get update. Second, run apt-get install nginx. Will it work? Yes, it will. It makes one redundant layer we mostly probably don't want to have. Then, second example does them both in single run statement, which brings you one single layer of the same size, but well, not exactly on the same size. It will be smaller than this combination together. And well, that's a pretty good practice to combine run operations together. I will show you, there are some tricks later how to do that. Then, redundant files. We try to remove all build time dependencies. So, don't forget, there is a build time when we do Docker build, and there is a runtime when we do Docker run. And there can be a huge time gap between those two. Or maybe runtime may never happen. It also may be a thing. So, what's the difference between first example and second example, and why I say second is better and first is worse? They do exactly the same thing. If you read that line by line, they will do exactly the same thing. they do apt-get update, apt-get install package I need for build. They build my application, let's say Maven install, if you stick to Maven. Then we get some cleanup work, so we get auto remove, we remove build package, we do a cleanup, and we clean up apt lists to remove repositories from local file. So does it look like a good job? At first, maybe, because we are doing all the cleanup steps. So that's great. We use it, some Maven, let's say, we build out image, but when we remove it, Maven, and everything we got during apt-get update, which is pretty heavy operation, we remove it during the last statement. So why it's wrong? Answer is, don't forget, layer is basically a change set, like commit in Git. Like commit in Git says those lines were added, those lines were removed. If you do all those operations in the different run statements, every run statement, technically, if we make a deeper dive, creates an intermediate container from the previous layer, executes the statements, and then commits this container to a new image. And as a result, first, we will have 3 different images here, 3 different layers. I don't care about intermediate containers, they are ephemeral, but we will have 3 different images here. And moreover, everything what we installed here, we will have here again. So we haven't cleaned it up, but basically increased it twice. Because we have layer here, and layer here, and layer here. First plus, then minus. And altogether it works like 2 pluses. Because we have a diff, we have a change set stored. And this...
So Alex, we have a... Oh, I'm sorry, Alex. We have a question that addresses this directly from Vikrant over on YouTube. Do we remove layers to reduce the build time? Like we get intermediate Docker image. Is each run commit to new images? Is this true?
We remove images mostly for transfer time, I would say. That's... those operations are pretty quick. So you may have 100 of empty layers or almost empty layers adding 1 bit. It will not be a long time for Docker to walk through all of them in comparison with one apt-get update, which in some cases with some custom repositories may take 5 minutes, let's say, under some circumstances. And as a result, those layers are mostly optimization for transfer time, not for build time. So, as a result, we have here exactly all the same operations, but executed with one single run statement. What does that mean? At this here before run, we create an intermediate container from the previous layer. So in our case, it will be plain Debian 9. In this container, we do all the job, update, install, build, cleanup. And when after that, we commit this image to be a next layer. And cleanup has been finished already. And that means what only new thing here is all the consequences of build my app. So for example, let's say a new jar file. But everything what was delivered with apt-get update has been removed already. And as a result, it doesn't fit into diff. It doesn't get into the Docker commit. And that's exactly like between commits in your Git repo, you can put whatever 10 gigabytes of videos of your family celebration, but if you delete them before Docker, before Git commit, we will not get there. That's exactly the same. I mean, that's exactly the same.
Yeah, that's a good way to put it.
Good. Now, sweet one. Multistage builds. Multistage builds, that's incredible. That's something new. Well, not so new, but yeah, it helps really a lot. Multistage builds allow you to use different base images at the different build steps of your Docker file. You have here an example, and that's not 2 Docker files. That's a single Docker file with 2 from directives. What's the trick? Usually your build time dependencies are much wider than your runtime dependencies. Especially when we speak about statically compiled files, those have all the dependencies you may need inside them. In this case, we work with an example of a Golang. And in the beginning, in the first line, we say from Golang 1.10 as builder. Notice there are no dash slim, no dash alpine or whatever. We don't need that. Let's take a look why. So this Golang image may be pretty big, I don't care. First, we set working directory. Second, we copy source code to this directory. And finally, we do run go build command, and we put everything to output file name at hello, so just file name, and we compile it statically. So it will have all its dependencies inside. And here magic happens because now we do from scratch. What does that mean? You know from, but how can we have two from in one Docker file? That's easy, we just switched the base image. We work it in Golang 1.10 and now boom, we work from scratch. Second question is, what's the hell the scratch is about? You never mentioned that. It's the kind of an application? Answer is no. Scratch is nothing. Scratch is zero. Scratch is empty and endless null. Scratch is literally an empty image, and when I say empty, I mean empty. That's kinda even more lightweight than Alpine, and it was hard, let's say, but yes, it's done. Then we have this CMD, this container as will execute /hello command, so the file we just compile it, when it will be started, and finally we use copy directive, but specifying from builder, and this builder is the previous base image we use it, and we copy file from tmp go hello to /hello. And our image will be based on Scratch and has basically only one layer due to this copy. And that's incredible, and that's the most lightweight container even possible. Statically linked builds, of course, are big by themselves. So this Go file, statically linked, will be more, let's say, will be bigger when not statically linked, and the same for Java files, for example, or whatever C++ you are using. But as a final result, as we basically cut off the whole operating system and put everything into an executable file, it will be smaller, and that's great. I like multistage builds. That's an incredible feature. I wanted to have. I should have had them like 5 years ago. They were in high need. It's very sad we didn't have them those times. Labels. So what is a label? In the Docker file, you may have a label statement which allows you to set label. And that's a very cool feature which allows you to set metadata for your images. Take a look at the second sample. Here we have maintainer specified, and as you see, it's crossed. Maintainer is deprecated. Maintainer has been deprecated, and you recommended to use label. And we can completely replace it with label, and actually we may have as much labels as we want to have. And label maintainer will be maintainer name, maintainer email. But actually, I may have as much labels as I want to. I can proceed right here, k2 equals value 2, or I can have a second line. It doesn't matter because labels don't create new layers after all. And that can be things like that.
Oh, so they're not wasteful in quite the same way as layers are.
Yeah, but they don't create layers, and they set metadata for the image you are building. And
by the way, Alex, we do have a follow-up on the previous question from, or the previous section from Vikrant. So in this, that hello.go will not be existing in our image, right?
In this, hello go will not be existing in our image, right? I mean, only executable hello will be available on image, not for code. Yes, exactly. Exactly. So as a final result, we have this new image, and it will has, we are copying only one file. We can copy more files if you want to, but here we are copy, remember, copy as specific as possible. So in this case, we are copying only one file, so we will have just one file, nothing more. Yes.
So it sounds like if you have something that's executable, if you're creating something that's executable, then the optimization is to use a multi-stage build and generate whatever is executable, and then in the second stage of the multi-stage build, just use that to execute the thing, and you're essentially discarding all of the artifacts you needed to build the thing in the first place with.
Yeah. And finally, which labels you should consider. I always recommend to set Git repository this project belongs to as a label. Doesn't matter if it's a proprietary project and you work with your team or multiple teams on the same project. It will help you. Or if you work, especially if you work on the open source project, that's also very important. Always specify a maintainer or better a team, because, well, maintainer may change. Team usually doesn't, or at least rarely. Then build number, or better even link if you build, for example, with Jenkins or GitLab. It's always great to include direct link to a build, so you can watch the logs if you want to check something, how it was built exactly. When build date always makes sense. Git commit hash always makes sense. And there are many more things you would like maybe to include into the labels. That usually makes sense. What's it all about? It's about to stay traceable. That's about to help people and yourself. After some months, you will forget everything. Help yourself to understand what's going on here, what this image is about. Stay traceable. Oh, now that's a sweet one. PID1 problem. Okay, so PID1 problem is a big deal. You definitely need to know. David, did it happen to you? What you are running some Docker container with Docker run without detaching that, so like it's attached to your terminal, and at some point you are done and you want to quit, and you press Ctrl C and nothing happens.
Yeah.
Sure, many times.
Yeah.
Same here. PID1 problem. So that all comes from Linux. Docker was built originally on Linux containers, LXC. And that all comes from Linux. The point is, in Linux systems, the process which is running first, so process ID 1 or init process or PID1 process, has some additional responsibilities. Well, every system has its own responsibilities. We use WhatsApp to send messages or whatever. I prefer Telegram. And that's the purpose of a messenger, to send messages. And every process has its purposes, but PID1 process has extra responsibilities. And those are as following. Rip zombies, pass back exit codes, pass through system signals. What does that all mean? First of all, rips zombies. What are the zombies? There are no exactly the zombies what will hunt for your brain, but they will hunt for your CPU and random access memory, definitely. Those are computer zombies after all. And those zombies are processes which are sub-processes. Those main processes, for example, fail it or quit somehow or don't wait for them. And sub-processes are in the endless loop or anything, or wait for the main process to accept the results, which will never accept them. Anyhow, those are forgotten processes. Usually, that's the responsibility of the main process who spawned them to reap them as they don't need it anymore. But if the main process who spawned them is not available anymore, they will be automatically attached to PID1 process, Linux. And if PID1 process is not ready to reap zombies, you will have zombies forever as long as container is running. To clean it up and to avoid memory leaks, your PID1 process must be ready to handle zombies, to reap zombies. Know what they exist and be ready to kill them as soon as they are not needed anymore. First thing. Second thing, imagine you have container of few processes running. It happens all the time, like Nginx may have some workers, or I don't know, Apache web server is going to have some process, and so on. If one of the processes exited with the error code, with exit code, non-zero exit code, it means that you have a mistake. Exit code is not 0, but 1, 2, 3, like whatever. Then basically it means what your application failed, was something is wrong. When you have to be notified, you would like to know if something goes wrong. But if PID1 process is not configured properly and doesn't know about this responsibility, even if this process tracks sub-processes, even if this process will exit as well, because sub-process failed, very often it will exit with exit code 0. And when you have a weird situation, something went wrong, your container exited, but it exited with exit code 0, which means in Linux world, hey, everything is fine, we are done, I finished my job. What do you mean you finished your job? You haven't finished your job. Why did you quit? I don't know, we are all fine. So, very important for PID1 process is to pass back exit codes. If one of the sub-processes exited with exit code 10, whatever that means, then PID1 should exit best case with the same exit code, or at least with exit code 1. Okay, something went wrong, take a look at that, master. And then finally, system signals forwarding, and that's exactly the point we mentioned before with David. Then you want to close your application in Docker run, and you push Ctrl+C and nothing happens. It means what PID1 process doesn't pass through signals or doesn't process signals. It has to process signals at first, and second, forward them to all sub-processes. And the problem is, most container entry point processes, Python, Java, even Bash, do not fulfill the PID1 process responsibilities properly. And when we run into a lot of weird situations. Okay, how to fix that? Fix before and fix now are two completely different things. Fix before was to launch your programs properly, have special scripts, have special treatments, have a lot of things to do, Docker run, install some process manager and so on. And now that's I'm really excited how it's solved, because now it's solved with just 6 characters on Docker run. Seriously. Let me show you something. So we have had those first sample applications, like very simple Flask application, Python application running. Let me make it a little bit clear. And I will do a little job here. At first, I will Docker run DML first Alpine just as it is. Oops, I want to run it in detached mode. So I will show it to you. Boom. Yep, it's running. And second, I'm running it again. I needed to use another port because AT is busy. And now I'm adding -- init. That's all I add. In general, they are absolutely identical. They different only in the port, which is not, which doesn't matter right now. And this -- init. Boom. If they say Docker ps, I guess you know what's going on. We have those two processes running right here. Now, let's take, and they look completely identical except of ID and name. But let me show you now something. If we go to first one, so I'm going to do Docker exec, I'm going, oh shit, that's Alpine. I launched it with wrong containers, I'm sorry. If they, as it's that's one of the problems, by the way. That's even a good example. I wanted to do PS aux to show you the processes, but I cannot do that because that's Alpine. There is no PS by default, so I have to install it. So I will kill those two, and I will run just first, and I will run again first. So I will have PS aux there. Good. Oh, that was a trick. Good. So now what I'm doing, I'm going to do docker exec for the one which runs the vault init command. And it was the second one, the newest one. So it will be 5aeb. Oops. And what I want to see is I want to see PS aux. So I'm executing. If you are far away from Linux, it may be a little bit not so obvious for you. But here I'm saying docker exec to execute a command inside the container. Which container to use? This one, 5aeb74 blah 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 blah. And which exact command to execute? I need PS aux to see the process list. And that's what I have. I have my Flask running, my Python running here, and I have PS aux. And who has the PID 0? Notice this, PID, process ID 0, my Python. And that's maybe not best in some cases, because Python is not a process manager as it is. You may implement all this functionality in your own application, but you have to implement that. Otherwise, signals will not be processed. And so on. And now I'm doing the same, but to take a look at another container. What was its name? 984. Okay, 984. Go. And picture is the different, although the absolutely exact same base image we're using. So I still have PS aux because I'm executing this command, so it fits into that. I still have this Python running, but this time Python has PID 6. And what's going on? Who is my hero here with PID 1? It's sbin docker init. This file was automatically injected to this container by Docker to help me to run Flask. And that's so-called tiny process manager or tiny init process, which does all the job I tell him to do. So all the dependencies we have here with all the PID1 process responsibilities, and it's doing them well. What is Tiny, you may ask? Answer is simple. There is a project pretty well known, like 5,000 stars on GitHub. And that's, as it's very well said here, tiny but valid init for containers. It's exactly the PID1 process, nothing more. It will pass through signals, it will pass back exit codes, it will exit as soon as the child process is dead, and reap zombies if there are any. Congrats, and all by the price of one single -- init command. Isn't that beautiful?
Yeah, like so I think what I'm hearing though is that if you're going to then use Docker run or whatever, that you should just use by default --init as part of your process.
Well, not necessarily. I mean, it depends on what exactly.
It depends what you're doing.
You see, that depends on what exactly you are doing. In some cases, I need one and one only process. It will never have any sub-processes. It will process signals, and there will be no zombies as I run no sub-processes. In this case, I don't need init. Yeah, so there are different use cases, but yeah, that's just important to understand what old times where you needed to install something in order to handle PID1 problem, they are not the thing anymore. It's done. Good. So no, we aren't always running --init, but in some cases it really helps. Well,
there is one other follow-up to that, by the way. Vikrant was asking, so this init, is it a kind of service manager?
Yes, it's kind of a service manager. Well, manager is a big word because tiny is tiny. It doesn't manage as it is. It's like, okay, child process is dead. I will die too. Boom, done. If there are any sub-processes reattached, rip them. If a signal has come, pass it through. And like that's not really a manager, that's the init process. Well done, tiny init process. We will work with process managers in a moment. Don't run in front of the train. We will cover that.
And then Arthur asks, is it possible to use --init with Docker Compose?
Well, actually, I never did that before. So I think there should be a way, but I didn't do it. Let's take a look. Compose. I cannot find anything in their main documentation regarding Docker Compose, but that doesn't mean I only can ask you to take a look, because yeah, I don't know, never took a chance to take a look at that. Okay, well then, we are moving on. Multi-process containers. So, if you watch for Docker best practices in the internet, you would mostly probably find something like that. One container, one responsibility, one process. And as a general rule, it's a good general rule I recommend to stick to. But what I'm doing here, what I prefer to do here is to add one more step or one more consideration. I prefer to think not on the one process, but on the one service. For example, it may be a real overkill to have in one single container Nginx, PHP, FPM, MySQL, and Memcache. If you are doing things like that, then mostly probably you are going to need Docker Compose and 4 different services. But, so I mean small services, not service like Facebook, but service like database or service like, I don't know, Redis. But in some cases, it may be a good solution. Why? Take a look. If you handle this stack I've just mentioned, Nginx, PHP, FPM, MySQL, and Memcache, for example, you handle only 4 containers, 4 services, and it's really easy to keep them together in Docker Compose. But if you handle the big system with hundreds of services, with a dozen of databases over multiple servers, you may want to simplify things for yourself. And in PHP FPM, for example, is the thing which doesn't serve on the normal port, but that's more of the sockets usually we have. And that's not kinda so HTTP based, let's say. We always prefer to have reverse proxy. We always prefer to have proxy server in front of PHP FPM. That's easier to explain like that. And if we have these Nginx and PHP FPM working together, as a result, we have one container with one port opened, ready to serve your all HTTP queries. So that's important to understand. What sometimes we do want to have multi-process containers. Okay, then are there any issues? Yes. Yes, there are some issues. That's not simple to run multiple processes in a containers. You need a manager. Do you remember PID1 process? Now it's even worse, and we have more things to do. So, that's not only now a thing to pass through the things. That's also a thing to manage them, to spawn them, and to understand their state. So, manager works is higher here. On the right side, you see a bad example. So we have 2 processes running in parallel, like let's say Nginx with childs and FPM with childs. and they are not managed anyhow. And if one quits, let's say FPM is dead here, what will happen? Nginx is running. Is this container useful anymore? No way. It cannot execute any kind of a statement, but it will be running because, well, we have Nginx, PID1 process is running. It can nothing, but who cares? And in this case, we have parent process, which is supposed to be a manager. So it will take care of a child process, quits if they are dead, and so on and so forth. Or maybe restart them, which is a bad practice. Okay then. So we need a multi-process init. We need to run multiple child process, but we don't restart them. We prefer to quit if one of them is dead. Here is a trick. A lot of people may say, okay, supervisor will restart my process if it's broken. So that's completely fine. Why do you say what do not restart them? Answer is simple. The point is, we may have multiple points or multiple layers of management and control over the application. So if we have supervisor, install it and restarting your processes, that's fine. But we may have one more layer of Docker and Docker restarting your process. Or we may have one more layer of Kubernetes or Docker Swarm restarting your containers or pods. Then how exactly you are going to manage the system if you have so many levels with different changes in them? That's not convenient thing. So in general, we always recommend process was dead, don't restart that, quit, call a daddy and ask him to fix this thing or whatever, who takes care of your system. Quit with exit code. So do not restart them. Second one, exit as soon child process terminates and still fulfill all PID1 process responsibilities. And in the beginning, it looks like we have a lot of init processes, different options, I mean. But as you start to get deeper into the list, you start to strike them over, like strike out. You aren't going to use them. So first of all, we have a lot of full-size Linux things like systemv, like Upstart, and many others. They are too big, they are too Linux specific, they are bad fit for a container, especially when we are trying to keep them smaller. Let's take a look later. Supervisor, use it very often. I do not recommend to use that. First of all, it requires a full-size Python environment to run, as it's a Python application. If you are running Python application, it's maybe fine, but if you are running Java, it's going to be stupid to have Java virtual machine and Python world at the same container at the same time. Other than that, supervisor tends to restart containers by default and maybe too big from my point of view. Then run it and mon it. Different projects, but I say it again like that. Too big, full size, and like do many other jobs we don't want to be done for container. We don't need so much. Teeny looks great, but that's not a multi-process manager. It's a simple PID1 process, nothing more. It's tiny, that's what we like, but if you want to run multiple containers, that's a no-go for you. And when finally we are having S6. And S6 as a special thing which was done from Linux developers to Linux developers. You will understand that reading documentation. And that's like not really good documentation. But so far it's one of the best process managers we want to have for multi-process systems. And there is a couple of things to mention about that, like what I do want to, well, S6 website as it is looks like that. No cheating, it really looks like that. Yeah, I told you, from Linux engineers to Linux engineers. And there is a one damn dozen of different, multiple dozens of different programs you may need, because they really stick to Linux approach, one process, one purpose. But there is something better you may like more, which is called, where is it? Give me a moment. S6 overlay. This one is the place to go if you want to have multiple processes for containers. It's a S6 process manager overlay, which allows you to run multiple processes at once and handling them properly. And notice in my last phrases, we never said word things like easy, simple, nothing like that, because, well, there is nothing like that. I'm saying about how to handle multi-process containers properly. As a result, can you run multi-process containers? Yes, you can. Can you do them properly, covering all the signals forwarding and all the other things and process management? Yes, you can. Do you want to do it? No, you don't. So still try to stick to one process, one purpose approach. It looks not nice, but it works. It's easier to configure in the most of the cases. Any questions?
Yeah, as a matter of fact, so as an example, talking about the single process, multi-process piece, is a Cassandra node cluster, would that be considered in one container? Would that be considered a container with one responsibility or one service?
Cassandra node, Cassandra cluster node is kind of course one one purpose, because, well, it provides the Cassandra port open, and you can do all the SQL operations you want to do with it. But it's also not a single process container. For example, when we speak about everything of Cassandra in Kubernetes, you are always going to have Cassandra as it is, but also a sidecar running alongside. Sidecar is a management process for Cassandra. So you already have two processes. And if we speak about DataStax Enterprise, there will be even more, because there can be Spark Worker and many others. So yes. So multi-process containers exist. They are in wide use. And if you see some complex configurations with things like S6 overlay, you will know why it is. It's not so easy to run multi-process container properly. That's why I suggest you to avoid that. That's possible. But it's also doable, so I did that. It all was working very fine.
By the way, from the question earlier, is there a way to use -- init with Docker Compose? Vasilis in YouTube did answer. He said there is a way to use init. Just add init:"true.
Yeah, exactly.
In your YAML.
Yeah. Thank you so much. Now, base images. So, in general, image rules are simple and very short. First, tend to use official images. Be careful with the latest image. Prefer exact tags when possible, or at least less generalized tags. I will explain in a moment. Use semantic versioning like in Git, or preferably exactly like in Git. If you release a new version of application version 3.5.7, you are going to release Docker image 3.5.7. And next point, if you are using custom base image, you have to rebuild it regularly, automatically, preferably nightly. So, what does mean custom base image? Imagine you have you are using microservices, you have 2 dozens of different Python services. Just for example, there is nothing about Python. And they all have similar dependencies, like some libraries, or they are all using, I don't know, gRPC or something. And of course that you can have all the installations in the Docker files per service, but it doesn't make so much sense, so you will have to do all the time the same job for different services. And if you have to add one single dependency or change a Docker file, you will have to change 20 Docker files. Traditional way here is to have your own custom base image, which uses inside, let's say, Python 3.7 Slim, as we have seen today, but you reuse that from, install the requirement dependencies, call it like your company name, Python base image. It may be a proprietary, let's say, doesn't matter in this case. And all your Python microservices are using this base image. So we basically just have to copy paste source code, but we don't have to install anything. So when build is very short and very quick. That's a very good way, so that's definitely a good practice, but there is a trap. So a lot of people get into this trap regularly. As they have their base image, as long as it works, they never rebuild that. And what it means, over time, month by month, maybe even year by year, base image of Python 3.7 will evolve, will have some security patches and fixes for the base Docker image it was using, also some Python improvements and fixes to 3.7, and you will never get this one if you don't rebuild your base image, because it's kinda cache, and if you don't invalidate and rebuild this cache, you will never get anything new, first of all, and second of all, after some years or months, you may find out what something has changed, and now you cannot build your custom base image anymore, and mostly probably you are going to find it out exactly on the hot time when you are going to deploy something right now, and you have to rebuild that, and it's not buildable anymore, and you have to spend a full day on debugging and fixing a Docker file. And that's, as you know, usually happens in the worst time. So my recommendation, use custom base image. Good. Now rebuild it regularly, rebuild it automatically, rebuild it nightly, and don't forget to use at least smoke tests, so you will be always sure what it's operational and build is really built. Now, I told you, be careful with the latest image. Prefer tags. But tags may be dangerous as well. In general, we speak about Docker images as immutable objects. If you have an image and you want to put any changes into this image, as a result you are going to have two images. One image is old and one image is old with fixes, so new. And you can delete old one, but the new one will be new one. So image is immutable as it is. You can create a new, you can delete old, but you cannot change old. You will always have new. And with tags, it works a little bit different way. So I have these three tags downside. And where is my pointer? And some of them are mutable and some of them don't. Now tell me please, David, how do you think latest is a mutable or immutable tag?
Well, I would think that is mutable because it's ever changing depending on whatever the latest version is.
Yes.
Whatever the, yeah.
So if you release 12.3.4, latest will be 12.3.4. If we release 12.3.5, latest will be 12.3.5. But if we release 12.5.0, latest will be 12.5.0. And if we release 13, right, latest will be 13. That's why latest is dangerous. Following semantic versioning, that's a major version. And it means what every next major version may, and very often will, have breaking changes. And at some point, boom, your system doesn't work. Why? Because you trusted latest image. And for some cases, for example, we at DataStax, for DataStax Enterprise, our kinda main product, besides Astro, of course, we have no latest tag at all. At all, there is no latest. You cannot do a Docker Compose pull DataStax Enterprise server. It doesn't exist.
That makes sense.
That's defense to avoid mistakes like that. So latest will simply not work with DataStax Enterprise server. When 12 is mutable or immutable?
Well, I feel like that might be mutable because it's not an explicit version, right? I mean, yeah, it's a major version, but what about the subversions?
Yep.
And what happens when one of those gets updated?
Exactly. We still have minor and patch version, and in 12, at least we promise to stick to major 12 version, but we will so we will not go to 13 or 100, but we still can have minor or patch releases inside. So it's kind of latest, but limited to version 12. Well, then this one is also mutable because we stick to major and minor, but patch may change. And now final question is this mutable or immutable tag?
I would like to think that that one is finally immutable when you have the tag all the way down to the patch.
Yes, and you are almost right, because there is one...
Oh, there's more?
No. That's one missing word. It should be immutable. Like with Git, you mostly probably know what it's a very bad practice to try to change tag. As soon as you set tag, and git push tags and your tags were delivered, you may never change them after all. Especially if you are not the only one who works with a repository. So, but technically you can, and that's very bad. And it's the same with Docker. 12.3.4 must be immutable, but it isn't. What I ask you, as we are speaking of best practices, please treat your tags and Docker image tags as immutable. Don't change them as soon as they are assigned. It may lead to a very bad problems. You will be hardly able to identify or debug. It's a really bad idea to have things like that. Well then, so all of the tags are immutable and it's bad. Oh, sorry, all of the tags are mutable and that's bad. So it's fine to have mutable latest, major, minor, but at least major, minor patch should be always immutable. That's what I beg you. Logs. So I work a lot with different developers and for many years, and two things I hate the most. Well, I hate a lot of things about how people do development.
Do I need to pull out some Alex memes?
Not now. So yeah, yes. But two things done the worst: logs and error handling. That's just a real disaster. How many developers don't understand what logs there are and how they are important, and how important proper error handling. Most of the developers don't care about the error handling, they're too optimistic, and don't care about the logs because they are not the people who maintain the application. And I spent so many sleepless nights trying to debug some systems, complex systems, but I was basically not able to do it well. I was able to do it wasting weeks because they simply write nothing to logs. Like nothing. Or just, okay, start up, boom, we are done. But no useful information. So logs are important. Three main things you have to remember regarding logs. First, logs should be. Point. You have to write logs, that's important. And if you don't know how to write logs, you have to go and read some best practices about the language you are working with, because that's really important. Second, that comes from 12-factor application methodology. I will maybe run a next course some months later. I really like this one. Every log is the event. Something has happened in this system. And those events goes into streams, so operations people when later work with them use some log analytic tools, use Splunk, Datadog, whatever GCP, Google Compute Platform uses, AWS has also some log analytics tools, and so on and so forth. Every log delivered is an event, and it has to be in the proper event stream. We will cover it maybe later, maybe some months later, I hope. But when we speak now most specifically, the rule is simple. All the logs go to /dev/stdout. Error logs go to /dev/stdir. You can send everything to /dev/stdout. That already will be great. My hero. Perfect. If you can separate good logs from error logs, so something went wrong, something went good, then it's even better because it makes much easier to analyze them. Then I analyze def_std_out from multiple servers, from multiple services. When we have basically to set up rules like if there is an exception, error, warning, we have to react somehow. But with /dev/stdr, that's much easier if there is something, when we have something to take care of. So def_std_out is good. If you can separate logs to good to bad, that's already great. If you're not so much a Linux guy, I cannot spend too much time on the Linux basics here, but just remember, so there are kind of devices or streams, better to say, in Linux. /dev/stdout standard output and /dev/stdr error standard output. And you have to send all your output of your application to those two streams. How to do that? It depends on your language. It depends on your framework. So I cannot cover all of them, of course. It will take ages because we have a lot of languages and frameworks. But in general, first read the documentation for docs, how to send logs to def_std_out, def_stdr. First, and second, if you work with an application which cannot send logs to custom places and always writes them to a file, and that will take 2 months to rework that, it's again fine. The only thing you need to do is to create a symlink, again Linux thing. So this file will not be a real file, but a symbolic link to the def_std_out and def_stdr. That's enough. And you are great, and your operations team will love you. And finally, that's a wrong place to put these logs thing into the best practices, because it's not a best practice, it's just a must-have. That should be a law. Like never write your Docker logs to a file. Always send them to def_std_out. And we are about to over. So few final words. First one, set the limits. Stay safe, stay on a safe side. First, you nearly never want to use root user on the production. Root user should be avoidable at all costs. It's fine to have it on build time, although there are people trying to avoid even that. But the first thing you have to avoid is to having root user running your processes in container after the build time on runtime. How to do that? Very simple. Only thing we have to add here is to specify which user we are going to add, and that's user's name, let's say, will be Alex. But as that's the Linux team, we have to create this user first. So I may want to have a run command with add user, add group, set user to group, and so on. That's kind of one more layer, but definitely worth safety worth this one more layer. For some base images like Node.js, you may already have default user node, and there are more things. So if you are using a base image, first check maybe it's already have prepared non-root user. Well then, let's go on. Limit, memory, and swap. This course is mostly for developers, and your laptop problems is your laptop problems. I care about your production. So that's usually not for developers to decide. But just know what guys on the production operations team will mostly probably run your container with limits enabled, and they will limit memory and they will limit swap. So you have to consider what exactly those limits are going to be. You have to avoid mem leaks, and those are things to consider definitely. How much limits to set, it very depends on your application. So here I cannot answer. Investigate these on your own, or let's discuss it at our Discord. Now, When possible, please use read-only mode using volumes or bind mounts. Like, what can be worse than downtime on production? Only one thing may be worse than downtime on production. Data loss on production. And
I think data loss might actually be worse.
Yeah, data loss
the examples
really may
I'm
be
thinking
worse.
about.
I mean, that's not there is no jokes. In many cases, data loss is way much worse than downtime. Speaking about data, try to use read-only mode when possible when mounting volumes. Of course, there are situations you may not avoid that, but in general, we do recommend to have this one.
Hey, Alex.
Yeah.
Fred over on YouTube is asking, how do we limit memory and swap with Docker run?
So there are directives in Docker run. That's I don't remember them directly out of my memory, but you can always find things like that. Docker run memory limit. It was something simple. Resource constraints, yes.
Yeah.
Boom, 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 boom. Memory swappiness, kernel memory, that's all good. That just dash memory. Minimum allowed value is 4 megabytes. The same for memory swap and so on. Kill disable, okay. Yep. So, now one more thing. For some of the containers, you may need more privileges than default container has. Some people tend to use dash privileged, but that's deadly unsafe because privileged container, especially when you run it with root user, going to have full administrative privileges on your computer, including host. And again, I don't get scared so much if it's your laptop, but it may be your production server with 200 CPU kernels and 300 random access memory gigabytes running thousands of containers. So
I would even kind of say, if it's something you don't want to do in prod, yeah, there might be some cases where doing it on your local environment is okay, but I wouldn't even get in the practice of it. It's almost like the same argument with using allow filtering. Why even get in the practice of doing it ever? And just do it the way you're going to really do it when you deploy the things. You're using the same kind of methods and processes everywhere.
Yeah. Like, may I jump out from this skyscraper? Okay, but only one time.
Yeah.
So yes, you can use dash privileged only one time. And instead of that, has some granularity with dash capability add instead option, specifying which particular extra capability you want to add to your container. That's cool. Pretty rare case, and in general you should avoid things like that at all costs. In some cases you may need them, but in general try to avoid that. Try to find better way instead of using capabilities add. Good. And finally, again back to Linux basics. Bash strict mode. What is it, how it works, and why you should care? Let me show you. So, and I think I will get second sample. So, we have here some lines which we have implemented pretty badly. And usually you can find improvements like that. Okay. So let's work on this code. Or actually, I will even add this line. So we have few lines of code, bash script, to be executed in the image we are building. And it will work. It's maybe not optimal, and we aren't doing cleanup, but it's not about cleanup for now. We are installing some things. What's wrong here is when you are running this script, any of those lines may fail. And what will happen then if, for example, this line fails? Nothing. Script will be executed further. And it's even not so bad if it leads to problem on build time. But in some cases, it may lead to problems on runtime. And if you don't detect that on time, it may break your production. Because bash by default runs in non-strict mode. But what I want to have here is I want to say bash, hey bash, we need strict mode. And that looks pretty, oops, I need to, yep. So that looks pretty weird, and let me explain you to it step by step. First of all, that's a short form. Full command will look like that. And there are some more. If you are a Linux guy, you may say right now what there are more options if you want to have the true bash strict mode. Yes, they are, but there are a lot of non-Linux people, so I'm trying to stay careful, not overdo. This is completely enough. This is completely enough for most of the cases. So first of all, what this line does, it says to Linux, fail on error in any line. So if I set -e, it means if this line fails, those two will not be executed, and Docker build immediately quits with an exit code. So I will at least know what something failed. Worse than error can be only error you don't know about. That's the story about -e. When we have -u, -u does the different job. You may use environment variables during your build, and that's actually pretty often case. And if you are using environment variables which wasn't defined before, normally, it will be interpreted as just an empty space. And that's like an old joke with rm-ref, some environment variable / some environment variable. But if you don't have those environment variables defined, you are going to wipe out your root folder. Because, well, that's empty / empty. And that's not what you want to have. So /u forbids usage of undefined variables in the code. So if I would try to do something here like that, I don't know, it will fail because this environment variables was never defined before. So the -u protects me from typos. If you define here get version, but you have a typo here and you have a new environment variable, it will not be executed like that, it will fail. And finally, -o pipe fail, it sets an option. With some commands, especially like that, like, I don't know, you have seen what I did today. Docker images grep alpine. If you have your first command failed, nothing will happen and the output will be forwarded over the pipe to the second part of the command. And you will never see this output because it's hidden by grep, for example. So -o pipe fail sets the mode. So if something on the left side on the pipe fails, overall script will be failed as well. So it's a bash strict mode, and when you have things like that, you definitely may want to have things like that. That's overcomplication, so we can make it like this. It will look better, and it will work exactly the same way. That's bash strict mode. Simplify it a little bit. Well then, and we are almost done. Health check. Now, that's funny. This new thing happened to be since year 2016, but nearly no one uses them. And that's incredible because that's actually a very powerful tool called Healthcheck. So take a look. We have an application running and Docker says it's running. So we say Docker PS, Docker says it's up. But how does Docker judges if it's up or down? Very simple. If PID1 process is running, we are running. Boom. But you know what? In many cases, it may be not the thing. In many cases, you need something more complex to define if your application is good or is up or down or something like that. Maybe it's in infinite loop, maybe something else, but it may be not operational anymore. Healthcheck, you may specify when you are running docker run command. You may specify healthcheck in the docker compose file, but the place to be for it truly is the healthcheck in your image, because as an image creator, you know how to check if it's operational or not. So first it starts with a healthcheck definition statement. When we define a command and what exactly we have to do to check the local application. If we are running something at port 8080, we can just make a simple curl. If the exit code is 200, we are good, exit 0 by default, or some Linux, exit 0. So if it's not exit code 2xx, then we are exit 0, and after a couple of checks, Docker will say what application is running, but unhealthy, and operations may have a warning what, okay, there is something to take care of, or maybe to restart or something. Of course, command may be much more complex. So you may grab for some output, assure what there is not only answer 200 code, but something more. Maybe your application doesn't have any open ports at all and do any another job. So that's better for you to decide how to check if application is running or not. And then finally, we may define intervals, timeouts, and retries. And if interval setting by default is more or less suitable, so timeout setting by default is 30 seconds, which is definitely too much from my point of view. So mostly probably you will need to decrease timeout time if your application is not able to respond within 10 seconds. I guess it's dead. And when we speak about Docker Compose, it looks like as predictable as here. We again define test and we define interval, timeout, retries, and you may have nice improvements like 1 minute 30 seconds, like with these amps and s. Alpha, all good seconds, never heard. Good. Final one.
All right, before we move on to the linters, Alex, there was a question with regard to the bash strict mode. Are those running per each instance of the run statement? And if I set it once like you have there, but then I have a following run statement, right? Do I need to reset it for each one?
In this case, this is why this one is a little overkill. First of all, let's take a look. -o pipe fail, except of this line which I've added, I have no pipelines here.
Right.
So it's redundant and we can delete that. And also, I don't have any user variables here. I can delete -u. And this one will be enough for those 4 lines. Because only what can happen if first line fails, I will quit immediately. And none of these set options will be applied to next run, because it will be a fresh new container. So
some of those, or if you had variables or something, then you can apply them again.
Yep.
Or as you've shown us before, combine those into a single run if applicable.
Yep.
Right, to reduce the amount of layers you have and such.
But for this single run statement, we don't need even this one. Because it's a single command, and if it has exit code non-zero, then Docker will treat this as exit code non-zero, build failed. So we again even don't need it at all. So
we're talking about multi-line statements.
Yeah, multi-line statements. And when we need these, why I still recommend to stick to this one. Very simple. Today, Here we don't have pipes and we don't have variables. Tomorrow we will. And the one who will add them will of course forget to specify it here.
And it won't hurt to have them there if you don't have pipes or if you don't have variables. That's not going to do anything extra.
Yep.
So you might as well just start there.
Yep.
I see.
Another option, what people do from time to time as well, I can show, instead of, how it's called in English, point and comma, dot and comma, like instead of this character.
Oh, semicolon.
Semicolon, you know. Thank you. Some people do that.
Yeah.
And that's another trick which may work, not so bad, but basically what it does, it just does the same job as set-e. So what's that? That means and. And that means what executes second command only if first one succeeded.
That's right.
And if update will fail, then second command will not be executed. Which one prefer, ampersands or set-e? I really have no idea. That's for you to decide what you prefer to have in your code. They both will do the same job. I'm personally using ampersands just because I'm used to it. So I was doing that like all life. But set-e, -u, -o pipe fail may work better, of course. Good. So we are done with health checks, and the last thing I'm going to show you today. You are tired, I guess, but stay strong. We are almost done, and then quiz, and I'll let you go. So, linters. If you are developers and you don't use linters, first of all, you should find a linter for your language.
So true.
Yeah.
So true.
Nothing to add. In short, what is the linter? Linter is the best practices check, automated check. So you can check the best practices of your Docker file even without me, which sounds good. Let's take a look at the example on the right. So there is a Docker file. You see lines specified by white from Debian, run, copy, run, expose, cmd. And by the yellow, you have the notices, warnings from linter. For example, from Debian, hey, always tag the version of an image explicitly. When we have node version is referenced by node assigned. Delete the apt-get list after installing something. What does that mean? We have apt-get update, apt-get install, but we don't have a ramirez. We don't have apt-get purge and so on, so we aren't cleaning. Our image will be too big. Avoid additional packages by specifying no install recommends. Yes, with this install we can bring packages we aren't going to use. Image will be bigger, but we will have, for no purpose. Then, here we are doing switch to usrsrc up and npm install static. To switch to directory, better to use workdir. Pin versions in npm. Instead of npm install package, use npm install package version. That's exactly what I told you before with apt-get install. Install versions. That's the best practice. And expose 80,000. Valid Unix ports range from 0 to 65,000. This is a wrong port. And there are some linters exist. That is an output of a hadolint. And there is a Docker linter and some more, I believe. I don't have experience with them, so I can't recommend them. With hadolint, you may play around directly live on the internet, so that's what I like the most. So I will not hide output. And I want to make it a bit bigger. I really like their logo here with this cat. That's amazing. But okay, so we have this file analyzed, linted, and I'm going to say from Debian Jesse, one of the versions, and I run lint. Okay, first warning is gone. And I may say no install recommends. And I'm adding it here. No install recommends. And I'm linking it again. Okay, it looks better. Then I can use workdir. Workdir. Run. And I'm going to expose not the port 80,000, but just port 8,000 link. Good. And so on and so forth. So you see, I've solved some of the warnings within just few clicks using Linter. And that's a web version. And you can also use, that's actually not what you could use, but what you should use. What I say, you have to install any linter, whatever you prefer, to your integrated development environment first. And second, you may need to add it to your continuous integration tests and code style checks if you have them. If you don't have, you should.
So Fred over on YouTube, and matter of fact, you just mentioned about integrating Linter into your IDE. So the trouble I had with the Docker file Linter in VS Code is that it checks only a file with the Docker file name and not anything else. And I have multiple Docker files with different names.
Okay.
I mean, it sounds like the Linter you just used is one way to do it, but I wonder if you have something else for him in VS Code that he could use.
The time I was I was working with Docker all the time was the times when we had no linters at all, and my best linter was here between my ears. So what I can say, mostly probably it's configurable. So I'm using VS Code and I have this plugin installed. So it says to me some warnings. And if I go to this maintainer, let me revert that. Yeah, so if I go, I want to revert that. Good. So it says me what maintainer is deprecated and so on. And I guess that should be configurable somewhere. We have to see configure file associations maybe for some special plugins. But to be very honest, yes, linked. So I think I have something here. There is the configuration and disable, enable, and install, copy extension settings. Maybe this one. Maybe we are going to have some settings here. I, to be honest, usually work with simple Docker file, so I cannot answer right now. But there should be a way to solve that, of course. Good. So that's the story behind that. And finally, we are getting to week 4 assignment. So, assignment of this week includes 2 steps. First step, that's about to optimize one of the Docker files of your choice. You can pick one of the suggested or find something on your own, what you would like to rework. Maybe some people are using Docker already and have some old projects they want to rework. Try to make it smaller, try to exclude redundant dependencies, try to keep Docker file self-sufficient. Think not only about the size as it is, but also caching and build time as well. For multi-process containers, as you will have some in the homework assignment in the GitHub repo, you may need Docker Compose to separate them, as there are some multiprocessing done not really correct. And second part, implement automated build from project 4.1 from previous point or from the last week using build server of your choice. We suggest Travis CI or GitHub Actions. Build pipeline should include at least Docker build, testing, at least some smoke tests, and Docker push to hub docker.com. If you think right now there are some topics, those are not covered in this workshop, of course, because it was all covered in previous workshops, or that's a request for you to dive into the documentation. And if you cannot do that, if you're stuck at some point, go to Discord. Link is on the right side, right above David. Or contact us by email. Discord is better. Good.
By the way, I didn't hear from Jack, but I do. Oh, he's responding now. But I do see that I dropped the link in the chat. There is a separate course or a separate registration at Eventbrite for the Kubernetes course next Monday. Oh, wait. Jack just responded, yes, but everyone who registered for Docker will be notified as if they have registered.
Oh, okay, good. So you don't have to register separately. You will get your clusters anyway. That's great. And what I can say, that's all, folks. You are great. Thank you for staying with us such a long time. We enjoying it a lot. And thank you, David. Thank you, everyone. Thank you, Jack. I see people answering questions in chat also from DataStax team. That's always a lot of fun to work together. And thank you for being awesome. And see you when in Discord. See your emails. I didn't answer all of the emails and all of the messages, especially on GitHub. I was very busy. I'm sorry. I will react to all of them. We just have some multiple projects in parallel, so I'm a bit tired. How it's called, torn apart to multiple projects. I don't know, maybe I said it wrong, but you know what I mean. I have too much on my table right now, but we will get back. I will get back to you in later on this week and answer all questions on GitHub, email, and Discord as well. Thank you for coming today. It was a great pleasure, and see you later next week.